10 fundamental Kubernetes concepts that you need to grasp as backend developer. Think of this as your essential toolkit for navigating the world of container orchestration. 1. Pods. The atomic unit. A pod is the smallest deployable unit that holds one or more containers, usually Docker containers. These containers within a pod share the same network namespace and storage volumes. Think of a pod as a tightly coupled group of containers that need to work together. Therefore, you don't deploy individual containers directly, you deploy pods. Understanding pods is the foundation for running your applications on Kubernetes. 2. Nodes. The workers. Nodes are the worker machines in your Kubernetes cluster. These can be physical servers or virtual machines. Each node has the necessary services to run pods, managed by the control plane. Think of nodes as the individual machines that do the actual work of running your containers. Your pods are scheduled to run on nodes. Therefore, understanding nodes helps you grasp the underlying infrastructure that powers your applications. 3. Control plane, the brains of the operation. The control plane is the central management unit of Kubernetes. It consists of several key components like the API server, scheduler, controller manager, and Kubelt on the master node that work together to make decisions about the cluster and respond to events. Think of it as the brain that orchestrates everything. You interact with the control plane to manage your Kubernetes cluster. It's responsible for maintaining the desired state of your applications. 4. Kubelt. The node agent. The Kubelt is an agent that runs on each node in the cluster. It listens for instructions from the control plane, specifically, the API server, about which pods should be running on its node and manages those pods and their containers. Think of it as the foreman on each worker machine, ensuring the control plane's orders are carried out. Therefore, Kubelt is the crucial link between the control plane and the individual nodes, making sure your containers are running as expected. 5. Kuberproxy. The network proxy. The Kuberproxy is a network proxy that runs on each node. It implements the Kubernetes service concept by maintaining network rules on the nodes. These rules allow network communication to your pods from inside or outside of your cluster. Think of it as the network traffic controller for your services. It enables reliable networking and load balancing for your applications running in pods. 6. Services. A service is an abstraction that defines a logical set of pods and a policy by which to access them. Services provide a stable IP address and DNS name for accessing your application, even if the underlying pods are created, destroyed, or scaled. Think of it as a stable endpoint for a dynamic set of application instances. It decouples your application consumers from the individual pods, providing reliability and scalability. 7. Deployments. A deployment provides declarative updates for pods and replica sets. It allows you to describe the desired state for your application. For example, how many replicas should be running and Kubernetes will work to maintain that state. Deployments enable rolling updates and rollbacks of your application. Think of it as the manager for ensuring your application is running with the desired number of instances and can be updated smoothly. 8. Replica sets. Ensuring desired number of replicas. A replica set is a controller that ensures a specified number of pod replicas are running at any given time. If a pod dies, the replica set will automatically create a new one to maintain the desired number. Think of it as the guardian that makes sure your application has the right number of running instances. Replica sets provide high availability and ensure your application remains running even if individual pods fail. Deployments typically manage replica sets. 9. Namespaces. Organizing your cluster. Namespaces provide a way to logically partition a single Kubernetes cluster into multiple virtual clusters. This is useful for organizing resources for different teams, projects, or environments, for example, development, staging, production. Think of them as virtual boundaries within your cluster. Namespaces help with organization, resource management, and can improve security by isolating resources. 10. Volumes. The persistent storage. Volumes provide a way to persist data in Kubernetes. Since pods are ephemeral, meaning they can be created and destroyed, volumes provide a way to store data that needs to survive pod restarts. Kubernetes supports various types of volumes, including persistent volumes for more durable storage. Think of them as the storage drives for your containers.